Hello, this is a problem, a comment left by a viewer. Now on this problem, it says consider for every real number the linear system of equations. You have three equations typed out here. Find the values for which the system has no solution, infinitely many solutions, and a unique solution. This is as far as I can tell, a linear algebra problem. So this looks like an advanced algebra problem for college level mathematics. And this is actually a big enough problem that it takes a while to do. So I'm going to break this up for you into two parts. I'm going to do the first part now and the second part later when I can get to it. And it'll give you time to think about it, and you may be able to come up with the answer. Now, to start with, I would just rewrote this as equation without the type. So this is what the equation looks like, the system of equation looks like. And normally, when you have a system of equations, you have constants that are just numbers. Here we got constants a plus 1, a squared. They all have to do with a, but they're constants, not variables. Let me go to the next slide. The way I'm going to try to solve this is just write a matrix. In this matrix, I'm basically going to translate this into matrix form. What I do is the coefficient of the variables. My variables are x, y, and z, and I'm going to write the coefficient, and I'm doing it in 4 columns. The x column, y column, z column, and then the other side. This is what is called an augmented matrix. And 3 rows. The first equation, the second equation, and the third equation. So the coefficient of x is 1. The coefficient of y is a plus 1. The coefficient of z is a squared. And the answer, or what's on the other side of the equation, is a cubed. So now I'm on the second equation. That coefficient is 1 minus a. And then the next one is 1 minus 2a. And for z, there is no z in this equation, so z would have to be 0. And a cubed again. And the next matrix I have 1, a plus 1, and then for z, a, and a squared. So this is basically just another way of writing equations. Now I've just put it into an equation form, a different form, and what I'm getting at is doing a reduced row echelon form. And when I get towards my final answer, all the stuff I do with the matrix, what I want to have is something that looks like this, if at all possible. Here you have stuff, and basically here would be your answer for the variable z, here would be your answer for the variable y, and here would be your answer for the variable x. That's what I want to get to. And the next step in the process is I want to get a 0 here and a 0 here. I'm doing what's called pivoting on this number. Now, it's because I already have a 1 here. If I didn't have a 1 here, I'd have to do something to change this row into a 1. And there's a couple of things you can do in a matrix. You can always swap one row for another. So I could put this row down at the bottom and take this row and put it at the top. You can multiply by a number. so I can multiply through by 2 and negative 2. And then the last one is you can put a linear combination of two rows and replace a row for linear combination of two rows. So that's something like you multiply by -1 and then you add the two rows. So that's what I'm going to do in this case. I want this to be 0, and that's what I want to focus on this first. So I'm going to make that 0 by, I'll take row 3 and add it to the negation of row 1. So this is a linear combination. One row plus a multiple of another row. If I put a multiple here, that would work. But this will get me 0 because I see I got row 3, I got a 1 right here in this spot, and then plus, if I put a -1, that's going to be plus -1, which would be 0, which is what I'm looking for. So first, I'm going to write this whole thing over. On the third row, this is what I'm putting in the third row. So row 3 plus -1 times row 1. So 1 plus -1 is 0. This one's a little bit more, well, this is, row 3 is a plus 1 plus negative a plus 1. Think about that. That's basically the opposite of whatever this number is, so that is 0. So 0 here. And so this is just pretty much just mess off to the side. The next one will be a plus negative a squared, which is pretty much, it can't be simplified. I could write the a squared first, but in the middle of the problem it doesn't make a difference. So a minus a squared, as far as I can get right there, and then the next one, a squared, think about it, a squared minus a cubed. So that goes in this slot right here. So I had to restart the software I'm using, but in this next step I want to get a 0 here. And basically what I'm doing is multiplying by a linear combination of this row, or a multiple of row 1. So row 2 plus a multiple of row 1 is basically what I'm doing. And I gotta figure out what my multiple is going to be. I need to get a 0 in that first slot. If you think about it, 1 minus a is a number, and I need to get 0, I need to multiply by the opposite of that number, the additive inverse. So multiplying by the opposite of that number, the opposite of that number is negative parentheses 1 minus a. So that helps me think about what linear combination I'm going to do. I'm going to do row 2 plus the opposite of 1 minus a times row 1. I need row 1 in there, and that's why I need a 1 here before I can do this step. Because when I multiply by 1, well, that's just going to be the same thing. And in other words, this is row 2 plus, if I take that negative and distribute it, I would have positive a minus 1. You think about what I did. All I did was I swapped the a and the 1. I distributed that negative. So this is what I'm doing. So my new matrix I'm going to, and I'm not sure if these are equivalent, but the equation, the answer comes out is 0, 0. So basically I'm rewriting those two rows, the top row and the bottom row, and the row I'm changing is the second row, the one I want 0, here. So if I think about, I'm doing stuff off to the side. If I think about what this means, I take row 2, so the first entry in row 2 is 1 minus a plus, I'm doing a minus 1 times row 1. What's in row 1? 1. If we do this out, you get 1 minus a. That 1 doesn't really do anything if I distribute it, plus a minus 1. Think about what that is. 1 minus 1 is 0. Negative a plus a is 0. That's 0, just like I've been saying. It's 0 here. Let me erase this, because those two say basically the same thing, but I don't want to go back and forth. So, again, 1 minus 2a plus a minus 1 times a plus 1. Now let's figure out what that is. It's a lot to do. I'm going to go through this quick. Distribute, I get the negative. The middle term cancels out if I'm distributing, and then minus 1 would be my last term. So here I got 1 minus 1 is 0, and I get a squared, and I get minus 2a. And that goes there. A squared minus 2a. This problem is it's a real process, so let me continue on. This next one I get 0, so that's going to be a little bit easier. 0 plus a minus 1 times a squared. I can drop that 0. A squared times a cubed, in here. So I'm working through that kind of fast, but you can always go back and make sure that that's basically arithmetic works out right. The next one, a cubed plus a minus 1 times a cubed. There's more than one way to slice that, but basically it's a cubed plus a to the 4th minus a cubed. A cubed minus a cubed, I get a to the 4th. Okay, now that we've got a 0 here, I want to pivot off of this point. So I'm done with pivoting here. I want to pivot off of this point, which means I need a 0 below it, a 0 above it, and I need this to be 1. And what I have to do first is make this 1. So I'm going to take R2 and multiply it by 1 over a squared minus 2a. And that's going to give me a 1 right there in that spot. When I think about it, I'm going to end up probably fast forwarding through some of this. That's row 1, row 2, row 3. Down here at the bottom, nothing really changes. I have to make sure when I'm rewriting that stuff, I don't make a mistake. That's easy to do. And then row 2, this 0 part, think about 0 times this. What would it be? Well, you get 0 on the top, a squared minus 2a on the bottom, which is fine because that just ends up being 0. Here I'm going to get 1. it is the a squared minus 2a times 1 over a squared minus 2a. Now I wouldn't ordinarily write this all out, but I want to get enough explanation of what's going on. So this should be a 2a, and find the eraser. So basically I had the same thing on the top and the bottom. I get 1, which I knew that was going to happen. The next one, I'm coming up with a fraction, and the key to solving this problem is thinking about what a can be once I get it into reduced row echelon form, where it's about getting zeros on the bottom. But you don't have to worry about, there may be ways to simplify this. You don't have to worry about that, because in the end it's not gonna matter. So now I have my 1 pivoted, and it's getting kind of sloppy, but you can sort of see where each entry is. This is row 2, column 4. But now I get my 1 here. I need a 0 here, which is convenient, and then I need a 0 up here. So I need to think of a linear combination of these two rows that gives me 0 here. I can't really use this row. It would never work out. So thinking about it, I need row 1 plus the I'm gonna do the opposite of a plus 1, because here's a plus 1 times row 2. So here you got a 1, so that works out nice. And that is the same thing as saying, let me do this out, I got minus a minus 1 here. So again, you rewrite all this stuff you're not changing. So row 1 is what I want to change. I want to get 0 right there. So row 2 stays the same. And row 1 is what I'm changing, so I should be copying that down. So I'm taking this and putting it in row 1. So the first thing will be 1 plus this times row 2, which is a 0, and get back a 1. And that's all that's going to happen. Now I got next entry, so off to the side would be a plus 1 plus a minus 1, negative a minus 1 times a plus 1. I'll put row 1, I need to put row 2 there, times 1. So working that out, and this is something that if you do enough of them, it has to be obvious, otherwise it's going to take you forever. A minus a, 0. 1 minus 1 is 0. So we get 0 plus 0, 0 here, which was the whole point. to be a squared, so I'm at this a squared up here, plus which is a lot to process, but you need to multiply that out and distribute that on the top. So distributing, I get, so I just did the distributing, and this turned out to be a long problem. I want to pick up on the rest of this next time, so I'm going to leave this for a later day. Thank you for the question. We'll get to the solution soon.